All right, good morning and happy Friday. It's July 28th, and I'm planning on doing the LeetCode Daily Challenge for today. So usually the ones at the end of the month here are a little more challenging. Yesterday it was a hard and I missed it. Dang it. Oh well, I'll fail for it. I'll eventually get it, so it's cool, whatever. I'm in it for the long run, right? This is more of a marathon. So anyhow, here we go. Predict the winner. So player one wins if there's a tie too. You have to play optimally. You can choose this guy or that guy. There's only 20 of them. Okay, so this one, right? Let's see, 8:54 in the AM. The game plan here is n equals 20. So just brute force 0-1 knapsack. Knapsack, I think, or no, this is actually a zero-sum game, right? Actually, yeah. I guess maybe zero-sum game. +1, or I guess positive for player 1 points and negative for player 2 points, right? And return true if and only if points is greater than or equal to 0. Okay, that's the game plan, right? So we reduce from outwards inwards. Let's see what happens. It only took about a minute to brainstorm a game plan. I don't think I've solved this one before. Otherwise, would have clicked the upvote. Right, seems like a pretty decent solution or question. Anyhow, let's do the implementation and we'll see what happens. So I is equal to n, that'll be our base case. N is the cardinality then for array A. And then we can either choose the left or the right. If we take the left, or actually we need I and J, right? Okay, hold on. Okay, so J's over here, and that's no good. Okay, equals J, then you have to take it as well, right? So if I is equal to J, return we set I. J is equal to n minus 1. Okay, so if we take the left, it'll be a sub I minus go I plus 1 J. Right is a sub J minus go I J minus 1. Return the maximum of left, right. Right, so the first time we invoke this thing, take whatever we have, and then alternating times it'll subtract from that. I mean, that's kind of what I was hoping for, but let's see what happens actually if we run this thing. I think that's the expectation. Oops, okay, hold on. So go is greater than or equal to 0 as the predicate. Should be false. Okay, that looks good. Oh, come on. And then we should be able to minimize this, right? If it TLEs. Okay, let's see what happens. The memo still should be good, right? 8:55 to 8:58. About 3 minutes. Okay, I'm gonna hit submit and see what happens here. Minutes. All right, cool. So that's accepted. It's awesome. It's top down. And actually, I think we can probably do this bottom up, right? And I wonder if it would be accepted without the memo too. Right, with the memo it's 32 milliseconds. Without, we'll just see what happens. And it's still accepted, so it's interesting. Okay, this I'll post as the art of dynamic programming because I think it's awesome. No, well, I mean, yeah, maybe I might have a biased opinion about that too. because I wrote it right. But let's try to do this bottom up. What would a bottom up solution look like? It's 850. I think we can do this, right? So I goes this way, J goes that way. They meet in the middle somewhere, right? What does our DP memo look like? It's a quadratic memo of all IJ pairs, right? So actually, let me put a little comment here for this guy. This is our memo, right? So we only have to solve overlapping subproblems once, and then we cache the response. Right, here's our target, which is the maximum. It's 407. That's the goal, is accumulate. These are our options. Here's our base cases. Oops. I mean, this is kind of what I look at, or this is what I see when I look at the code. Base case. Base cases, right? Whatever. It'll cover this one, and the one below it is cool, right? Okay. Let's just grab this. It looks nice. Okay, there we go. There's our goal. Oops, okay, hold on. Let me just modify this bottom up the best I can here. So I is going from left to right. So if, as a recursive stack on line, it's going to go from right to left after it meets up with the J, which goes as a recursive stack on lines, it goes the opposite way too. So for I and first range in our DP memo 0 times n plus 1 is less than J. Okay, so looking at our recurrence relation, looks like we don't need to put the base case here. We need to create the base cases when I equals to J. And then these ones are explicitly will always be 0. Okay, so this is will be our memo. Oops, our DP memo for explicit bottom-up states. So this is a little bit tricky in that it's implicit top-down, but it has to be explicit bottom-up in order for us to iteratively build upon it, mimicking the recursive stack unwinding. So for I in range n, BP sub I equals A sub I, right? This is when I is equal to J as our base case here. That guy. Base case, okay, the other base case, this is implicit, right? So I guess plus base case, we'll just be very explicit about that. J is less than 1. Okie dokie. Let's do this. It's equal to J. And this is plus the memo. No. Just stick that right there. Okay. And then for, so J goes this way as our When lines goes that way, chain range in. Chris's technical lines will go that way, right? So let's see. So we can basically copy and paste this stuff here for the most part. And then we'll return dp sub 0 sub n minus 1 exceeds or meets 0. That's our predicate. All right, so that's pretty much that guy. And then instead of returning, we'll just set our dp state ij, maximum L and R, and this will be our dp state ij as well. Oops, P. Okay, something like that. And then I'll just grab this guy. Okay. All right, let's see what happens. It's 9:05. 6 minutes. What happened? Uh-oh. I plus, oh, dang, okay. Minus I plus 1. I plus 1. Oh, yeah, okay. J minus, oh, dang. J minus 1 is going to be 0 as well. Okay, so if I plus 1 is less than n and 0 is less than equal to j minus 1, and we don't want to go out of bounds. Okay, let's see if that happens. Okay, that looks good. And yeah, let's submit it. 9:05, 6 minutes. So, okay, so this is not correct or a wrong answer. Bottom up. Oops. See if we can fix this thing up. And then let's see, this one was accepted. Okay, yeah, so here, so 8:58 is about 4 minutes overall. That's pretty good, because I haven't seen this one before. So that's pretty awesome. Upload this thing. All right, okay, so this guy, I'll start debugging it and see if we can fix it up. And if I'm not able to fix it here in a few minutes, I'm gonna may just come back to it. What's going on here though? We're saying it's true, but it's supposed to be false. Which should be false. Okay, so player 1 is not guaranteed to win. Let's look at what we got here. How does this work okay, but then this one fails? Oh, let's see if. Okay, I see. Okay, so. Okay, let's continue, right? So if I is less than, right, or j is less than I, or, oh yeah, let's do it. If I is equal to j, or j is less than, okay, this one is straight up dp sub ij equals, we'll just do I, sub I. I'll just say this is a base case. So we don't have to explicitly set it, we'll just do it here for convenience. Let's move this guy up here a little bit to align it. Okay. If j is less than I, we'll continue. Okay, so we never want to consider j is less than I, so we might as well go from I to in here, so we don't have to consider that, right? For J and I. Well, let's do this I+1, and then, yeah, I like having the base case up here. Do this again. Just so we don't mix up the base case and the recurrence relation, right? Make our lives easier, hopefully. Okay, so J will never consider the ones where it's less than I. The base case is when J is equal to I. And then here, okay, let's see what happens. Maybe that'll do it. It should be false. Okay, cool. Let's do the, oh, what did I hit? Okay. Sample test cases, make sure there's no regression, and then we'll try again. It's 909. Oops. Oops, lock. Okay. Big money, no whammies. Yay. Okay, cool. So that's 3 minutes to debug. Bottom up, right? I missed a couple of corner cases. So total of 9 minutes. Oops, minutes for bottom up. Okay, cool. And then for folks that are watching, this is something that I've been practicing for about like 4 or 5 years, right? So this is not something that's really that straightforward. It looks simple when you look at the answer, but the process of driving the answer is where the difficulty is, right? And the process of actually realizing, okay, this is DP, is the majority of the problem solving, right? Okay, categorize it based on the characteristics where we can solve it in a meaningful way, right? So here we go. Right, okay. So anyhow, I'm going to take this guy and post it, and then I'll add it to my GitHub repository I've been maintaining as well. And the purpose of this, or the end goal, which I'm trying to accomplish, my intention is to be helpful, right? So this took me a long time to acquire some of this information, and I'm sharing it willingly for free, to anyone that's willing and able to listen. So, I do request feedback. If you all find parts that are beneficial, let me know. But regardless, this is beneficial for me. So that's why I do this, is for myself and others, right? Not just for others, but it's important to have a healthy regard for a sense of self, right? So you don't become a doormat giver. Okay, so anyhow, let me pitch this up here. This is the overall game plan. This is what I did. All remember turn. Basically, take all possibilities, remember it with a cache, and then turn it upside down. Right. So the base cases are implicit, as well as the memo and the top-down solutions, and then it's explicit in the bottom up. That was, we have to explicitly state the base cases before we iteratively and optimally build upon them in the bottom up. Oh, that reminds me. Yeah, I wonder if we can do a memory optimization. Usually that's the last step, right? If the current row is dependent on the previous row, then we could do that. But IJ don't seem like they're aligned quite like that. Yeah, sometimes you can do memory optimizations. You really look at this carefully, but yeah, nothing's shown up to me offhand right now, but I'll come back to it. Anyhow, dynamic programming is a challenging thing, and that most people I see, they post their solutions here. It's like the most concise solution they can come up with, which is highly refactored. It doesn't really go through the process of how it was derived, and usually it's the bottom up that folks will post. And that's, I don't think that's helpful. It hasn't ever been helpful for me. I like look at some folks' solutions like, how did you get there? Like, so this is exactly how you get there. These are the breadcrumbs of the steps I took. And yeah, there we go. Okay, so I'll post this guy, and then take this guy and we'll add it on to this guy here, which is my ongoing repository solutions for DP. Okay, so predict the winner, 486, 46. Boop. Okay, and then this guy, oops, not most votes, but oldest to newest. Grab that guy, stick him in here. Pick the winner. Okay, let's stick it here. Here, 46. Okay, and then I'll just add it here real quick. Okay, that guy. Okay, there we go. And I might come back and do this in other languages. We'll see. Maybe I'll save it for another day. It's a pretty fun question. I like it. Okay, anyhow, I'll catch y'all later.